Right. So for the hypothesis testing now, that would be instruction number 13, hypothesis 3, hypothesis 4, hypothesis 5. Hypothesis 3 says, let's go to hypothesis 3. Let's go to the template itself. All that is under data analysis. It says the average mathematics feeling is less than or equal to 65. The average mathematics feeling is greater than or equal to 60, is greater than 65, and here it is in symbolic form. So you need any hypothesis test that you have to do. We just did the topic there a while ago. I'm preparing the test for you on it. Test C. You have to state your pair of hypotheses, and we want it in symbolic form. So you have to copy this and then go down to write hypothesis test. And if you can even put hypothesis as a subheading, hypothesis 3, I think. Yes, that's your first step. You can even put the centralized, up to you. All right. And then now, remember, it's Excel you're using. So therefore now you go back to Excel. So you'll not be drawing the curve and calculating the and those things there. Excel will do that for you. So you just go to Excel and you go to hypothesis 3, Z-test forming positive math feelings. So let's go and get the positive math feelings. So you just copy the positive math feelings and you go back to hypo 3, positive math feelings. Okay, and your dummy is 0 because remember, Excel is programmed to compare two variables. That's how they program Excel, but it's one variable you have. You see, so therefore now we have to try to fool Excel by creating a false variable and then now give it a value of 0. Now to complete the Z-test forming using Excel, you have to include the variance of your values. So that's not a problem. You just go to cell 42, okay, A42, and you go to formulas, go to insert function, and you go to variance of the population, okay, VRP. Okay. Oh, you have to indicate to Excel which numbers you want to find the variance of. You want to find the variance for A2 to A45. And look at give it there for you one time, 612.89. 612.89. So this is the variance that you've got to use when you are performing your forming for this example. So now what you do now, you indicate to Excel, probably that's where you want the output to be. You go back to data, you go to data analysis, and then you look for Z-test for mean. So you see Z-test for 2 samples. That's why you have to create a false variable there, a false sample, because that's how the programmers program. And you have the t-test. We never even talk about the t-test. Remember I told you there's many other tests, you know. There's what you call the t-test. Okay, I wanted to introduce the t-test. There's a very popular one called ANOVA. Okay, for those that look at the ANOVA there, for those of us who do agriculture, Mr. Alexander talking about the ANOVA, you know, it's a very important hypothesis test. Okay, but for this course, we have the Z and the chi-square, but there are many more. You have the F-test, look at the F-test there, and there are many others. The Z-test, 2 samples, you click on it and you click OK, and then you indicate which first variables, from where to where. From, make sure the cursor is ticking there. See that vertical line blinking? So you go there and then you indicate to Excel, that's your first variable. Second variable, it's asking for second variable. So you're going to key on it if you want to put it that way. So you see second variable is there. Okay. Then it wants the hypothesized mean difference. So the hypothesized mean difference now is the mean difference it wants, not the mean itself, you know. You see? That is the other thing about the z-test for mean here. It is comparing two variables. Okay, so the mean difference there now is, remember, is 0 we have, so we put our mean difference now. 65 minus 0 is not so, it's 65. But if you add another mean for the second variable, you have to subtract to get a value. That will be another type of, you might do that in university. But since let's go back to it, we put a, so it's 65. 65 minus 0 is 0, because it's not asking for a mean, you know, it's asking for a mean difference. Okay, which is 65. 65 minus 0 is 65. It wants the variance of that first set of values. So that's where was 612.89 coming. 612.89, right? 612.89. Right, 612.89. And for the dummy variable now, you don't put 0, you put a very, very small number. They must have a variance, okay? Any set of values must have a variance according to what Excel. If not, then it will be the same set of numbers. So you put a very small number, and then you leave everything else as is. Significance level of 0.05, that's the alpha. Because in a p-value approach, we're going to apply. You have what you call the classical approach when you draw the curve, but with Excel, we're going to use a p-value approach. So we're going to make use of that alpha, that significance level. Okay, and you click OK. As you can see, if you go back to the instructions, I took the time to include the steps for a p-value approach using Excel. State a pair of hypotheses, input the data, which we did, process the data, identify the p-value, and compare it to the 0.05, the same 0.05 I showed you, which is the significance level. Reject the null if the p-value is less than the significance level. Do not reject the null if the p-value is greater. And then you conclude according to what you decided to do. So what you do now, you open this a little bit, just double click there to open this wider, double click there. Okay, copy this table, paste it under your pair of hypotheses. Right? So that's the first table. So you call that table 1. APA. Okay. And then you under it now. So we have to go in another page. And go under the table. Right. As seen in table 1, the p-value. Now there are different p-values. You have p-value for 2 tail and for 1 tail. The 1 tail doesn't tell you left or right, it's just 1 tail. So the p-value is 0.129 or 0.3, 0.13, because it's a 1 tail. All right, the hypothesis 5, that's a 2 tail. So hypothesis 5, this is the p-value you'll have to use. You see, look at the critical value right there, you see? And then you have what's the p-value? Look at the z, look at the z, and the critical value, 1.96, okay? Remember the critical value on the tail, on the critical point, and then the z, okay? So that will not be in the shaded region. So if you can even use a critical approach using that figure, and the critical approach comparing critical and the z. This 1.19 will not be in the shaded region because it's from 1.96 and upwards. That will be the rejection region. So if you're using z and z critical, then you'll have to not reject the null. But it's the p-value you're using, and the p-value is 0.13 is greater than the significance level of 0.05, yes? Yes, yes. So therefore now we are not rejecting the null. The null is not rejected. Okay, and not rejecting the null, therefore now, since we did not reject the null, then yes, the mean is less than 65. That will be our conclusion. And that's what you do for the remaining hypothesis test for 2, for 3, 4, and 5. Okay, 5 will be a two-tail. Okay, so for this example, since the p-value is greater than, the null hypothesis is not rejected. Therefore, the mean is less than 65. Okay, and you repeat that for hypothesis 4 and 5.